Hey everyone, today I'm going to be showing you how an ultrasonic cleaner can create waves that are so strong it can even dissolve solid metal. So look at this magical cleaning power of the ultrasonic cleaner here. I'm just going to draw on this piece of glass with a pencil here. So you can see I can wiggle it around in the water, but the pencil marks just stay there. So they're not easily wiped off. But now I'm going to turn on the ultrasonic cleaner and watch what happens to the pencil marks. They instantly just come off of it. So how is this working? How can I clean things so well, like this bolt here? Notice how the dirt and grime just come off it instantly when I stick it in the ultrasonic cleaner. Well, we know that it has something to do with sound. It's called an ultrasonic cleaner. At the bottom of this metal piece is an ultrasonic transducer. Basically, it's just a device that vibrates around 42,000 times per second. So you can't hear the sound from it because it's above the frequency that we can hear. That's why it's called ultrasonic. But you'll notice that we can hear a little bit of sound. That's just the pieces of the machine vibrating in the audible range, so we can hear that a little bit. So this bottom metal is vibrating at 42,000 times a second, sending sound waves through the water. A sound wave just means that you have pushed molecules closer together and further apart at a regular frequency. So when you create regular sound waves, it just creates pressure waves that propagate between high and low pressure. This deviation in pressure in the sound wave is called acoustic pressure. For a given amplitude, the higher the frequency of sound, the higher the acoustic pressure. So if we want to create extreme high and low pressures, you can either turn up the amplitude by making the sound louder, or you can keep the amplitude the same but turn up the frequency. The ultrasonic cleaners have extremely high frequencies, which means they can create extremely high acoustic pressures. So if we send an ultrasonic wave through water, then something interesting happens. Notice that we have a peak of high pressure and a peak of low pressure, but there's a limit to how low we can get the pressure in water. Once the pressure is below the vapor pressure of water, then the water actually turns into a vapor. When this happens, it's called cavitation. Cavitation is tiny little bubbles that happen in the low pressure regions of the sound wave created in the water. These bubbles themselves don't do much to clean things. For example, I can boil water in my vacuum chamber by lowering the pressure, but that doesn't mean that I can clean something in the water. It doesn't really do anything. The cleaning power of the ultrasonic cleaner comes from when these little cavitation bubbles collapse and form a liquid again. So what happens is during several cycles of the sound wave, the cavitation bubble gets bigger and bigger and bigger until eventually they pass a critical point. At that point, they instantly collapse into a liquid again. Now this collapse in volume is so sudden that it creates extremely high pressures, above 1 gigapascal. That's above 1,000 atmospheres of pressure. And it creates temperatures above around 10,000 Kelvin. In fact, the collapsing bubbles even create shock waves in the water. That means that it's moving faster than the speed of sound in the water. So these tiny little collapsing bubbles are what actually do the cleaning. So that's why when you stick something dirty in the ultrasonic cleaner, the dirt just seems to melt off. If you don't believe me how strong these bubbles are collapsing, then you can actually watch them eat away at this metal foil here. You can see it instantly begins to get eaten away when these tiny little bubbles form on it. This is so crazy. Okay, I'm going to turn it on in 3, 2, 1. So this brass foil just becomes dust as these ultra high speed, pressure, and temperature waves hit them and just disintegrate it into dust. What's really cool is that you can see the acoustic pressure even better if you put some soda water in the ultrasonic cleaner. So you can see how it's kind of just bubbling out a little bit, but watch what happens when we turn it on. 3, 2, 1. As soon as you turn it on, it'll instantly cavitate the water and the CO2 very fast. So you see the CO2 instantly leave the water. The cavitation doesn't only happen in ultrasonic cleaners, it happens wherever you get low enough pressures to create cavitation. In fact, cavitation can even happen on propellers in water. If they're spinning fast enough on the back edge of the propeller, the pressure gets low enough to create cavitation, and these collapsing bubbles can eat away at the metal propeller. And thanks again for watching another episode of the Action Lab. I hope you enjoyed it. If you did, don't forget to subscribe to my channel if you haven't yet, and you can also hit the bell so you can be notified when I release my latest videos. And check out theactionlab.com for Action Lab gear. And thanks for watching, and we'll see you next time.